morning, everyone. My name is Dmitry Polzikov. I'm from the Russian team. And today I have a difficult task to speak in the end of the conference and after our wine tasting, but I hope that I will handle it. My report is about assessing multiplier effects in the Russian economy. It consists of two parts. The first part I will talk about methodology, and in the second part I'm going to tell how we apply this methodology to assess contribution of a specific sector to GDP. Before I get started, I should say that we are not pioneers in this field, as I understand, and we use some techniques that are well known. There were similar reports in previous days of this conference, so I will describe general features of our approach, just for your information, and then later you can ask me about the details. We can discuss these details. So, about some slides about methodology. We consider several types of multiplier effects. The first one is single output multiplier effect. To assess it, we can use the basic IO model. This one. In this framework, single output multiplier, to assess single output multiplier for a specific sector, we should sum up components of the appropriate column in the matrix of total requirements. It's a classical approach. And then we can use proportions between value added and output in various sectors of the Russian economy to assess impacts on GDP. The next type of multiplier effects that we consider is induced effect. We should have relationships. We should establish relationships between value added and value added block and final demand block. We assess some elasticities, for example, income elasticity of household consumption. We use the data on social economic accounts provided by the Russian statistical agency Rosstat. We have several stages of calculations. First of all, we should assess increasing wages, taxes and profit. Then we should move to estimates of induced final demand and induced final demand for domestic products, goods and services. And then we can use the approach described earlier to estimate impact on GDP. That's also a classical approach. The third type of multiplier effect is investment multiplier effect. Generally, it's the same approach, but on the first stages of our calculations, we should evaluate find fixed capital formation increase and final demand for domestic products, investment products. We usually apply this approach for assessing macroeconomic impacts of future projects and future government spending programs. But today, I would like to show that this approach can be used for the purposes of retrospective analysis. For example, I would like to evaluate contribution of a specific sector to GDP. Since I'm responsible for agricultural and food production projections in my institute, I prefer to choose these sectors to do such calculations. The statistical base of our calculations is a series of national income output, input-output tables elaborated by my colleague Marat Uzyakov. These tables are in current prices, and these tables are for the period 2000-2015. We made our calculations separately for each year of this period to assess multipliers, output multipliers and investment multipliers, and then we use data on outputs and investments in food production and agriculture to evaluate impacts on GDP. But there are some methodological issues that we should deal with. The first one is that actually we do not have data on initial final demand increase. All that we have is the data on resulting final demand and resulting output. So we should adjust our technique to make it suitable for this kind of calculations. For example, we should normalize our multipliers. For example, in 2000, 1 ruble of output in food industry resulting in 2.4 rubles of total output, including 1.4 rubles of output in food industry. So we should divide 2.4 by 1.4 to establish relationships between resulting output in food industry and output in the rest of the economy. The second issue is that we need to avoid double counting, because we estimate multipliers for agriculture and food production separately. We have special procedures to do it. For example, if we assess multipliers for agriculture, then we should exclude food production by setting to zero the row of coefficients, technical coefficients, that is related to agriculture. All right, let's move to our estimates. Here we have estimates for multiplier. We have two graphs. This one is for agriculture and this one is for food production. This line is for investment multiplier, and this is impact of output on GDP. I would like to mention that direct impact of output in agriculture and in food production is increasing. It's due to growing productivity in these sectors, improving its technologies. And here we have the estimates for total contribution of agriculture and food production to GDP. This is the direct impact of output. It's stable, and we estimate it at 5% for agriculture and 3% for food production. Total impact is much higher, but it's reducing. And that's a surprising result, because in Russia, it's common point of view that agriculture is one of the main drivers of Russian economic growth. But our calculations show that that's not true. Russian agriculture was growing. Last 20 years it was growing by 3% per year. But if we take into account the induced and direct effects, then that's not true. The total contribution of agriculture and production to GDP is reducing. That's a similar result that was obtained by Sergei Belyakin in his presentation. There are some factors of this reducing. The first one, in my opinion, is that Russian agriculture became more competitive, more efficient, more productive. Here we have the retrospective dynamics of key technical coefficients for Russian agriculture. And we can see that intermediate consumption of such inputs as feeds, seeds, electricity, fuels has decreased significantly. And there is only one coefficient that has increased. This for financial services and insurance. And it's due to using loans to fund investment projects in the sector. The second factor of reducing contribution of agriculture and food industry to GDP is growing productivity in the Russian economy, not only in the agriculture sector, but in the Russian economy as a whole. Here we have a graph that shows the dynamics of primary resources used to gross output ratio, and it's steadily reducing. That's the result of growing productivity in the economy and structural changes in the Russian economy. This graph is the same, but in current prices. This one is in constant prices, and this in current prices. And we see that intermediate consumption is reducing. Share of intermediate consumption in gross output is reducing, and primary resources consumption and other manufactured goods consumption is reducing more faster, much faster. But the share of services consumption is increasing, and that's another factor of reducing of multiplier effects for agriculture, because service activities usually, as a rule, have lower multipliers. All right. The third factor of reducing is increasing shares of import in final and intermediate consumption. We can't say that this share is steadily increasing, but as a rule, if we have significant economic growth in the Russian economy, we also have increasing shares of import. I come to my conclusion. The first one, maybe it's trivial, but I would like to say it. We can use input-output approach not only to assess macroeconomic impact of future projects, future government spending programs, but also for various purposes of retrospective analysis. The second point is that agriculture and food production remain an important part of the Russian economy. Direct impact of these sectors is estimated at 7 or 8%. Total impact on GDP is much higher, but decreasing. And the main factors of reducing this total contribution of these sectors to GDP are technological and structural changes, growth productivity in Russian agriculture and in the Russian economy, and increasing input shares due to integration of the Russian economy into the global economy. That's it. Thank you for your attention, and I'll be happy to answer your questions.
Okay, who will be the first?
This is very good presentation. I think supplementary thing would be here about the role of agriculture in Russian economy. Linkage analysis, not very time consuming. You will see, you will have a classification, key sectors, supply-oriented sector, demand-oriented sector, weak sector. And I suppose that this will be key sector, as in Poland is also agriculture among key sectors, and this will be explanation why your topic is also sector in this sector agriculture in this analysis. This is only suggested.
Thank you.
Dmitry, thank you very much for your presentation. I just would like to say several words as a comment. So, when we calculate multipliers in the economy, it's necessary to take into account peculiarity of investments. So, if you make investment in this year, because of distributed investment lag, you will have effect not only in this year but in future.
Yeah.
In this sense, when in my report I told about multipliers, it's necessary to say that our model take into account distributed lags for every industry. And before to calculate this model, we estimated distributed lag coefficients using special mathematical problems of mathematical programming. So it's a big job and work. So my recommendation in future to have in mind that multipliers is not static. We have in economic dynamics multipliers distributed in time. Thank you.
Okay, I would like to make it clear. We do realize that our approach is simplified. We have a lot of simplifying assumptions, and we usually use this approach just to make some express estimates, calculations, and we do not use dynamic IO models, but Alexander Shirov uses dynamic models and distributed in time models for his calculations. So I think that's the right comment. I totally agree with you, but we use this tool just for simply calculations. So I will collect it and I will deal with it in my future research. Thank you.
Nie wiem, że inwestycje jak inwestycje w tym числе. Ну что ты скажи.
No, I don't. Sasha said that we have some procedures of dynamization of our calculations. If we, for example, assess macroeconomic impacts of future projects, we can dynamize IO coefficients and some final demands elements, but for this type of calculations, for this kind of calculations, in the retrospect, I think that it's very difficult to take into account these time distributed effects. And I think that if we use the data on investment capital expenditures in agriculture and food industry, and these capital expenditures are stable from year to year. So we take into account this investment lags.
Any more questions? Dmitry, thank you very much.
Thank you.